Observing quality, observability-driven testing in financial systems. Se trata de exploraremos las prácticas y beneficios de usar herramientas de observabilidad y cómo mejorar la automatización de pruebas para anomalías de transacciones de pago, rastrear excepciones más profundamente en el código y en el sistema. We will explore the practices and benefits of using observability tools and how to improve the test automation for payment transactions anomalies and how to trace exceptions more
español.
deeply in the core and
Yes,
system.
she'd switch from español to English to español.
Welcome, Mark. All for
thank
you.
That was good, Anna. Gracias. Muchas gracias. Hello, I am Mark. Welcome to, it's nice to be at the third QS-Conf. I was at the first one, I was the second one, and here I am at the third one. What? It's beautiful. All right. I would like to talk about observability within testing, and I may have invented, you guys look it up on Google. Did someone else craft observability-driven testing? Because I'll talk a little bit about that. I don't know if I coined the phrase, but it made sense. So there it is. I'm just going to use it. It's fine. A little bit about me, as Anna said. I'm a full-time tester. I do full-time test execution. In fact, right now, I'm running tests. And then I'll get interrupted at some point to analyze those results. We still run all the gates. I do all the automation. I have a team of 2 other testers that work with me. But that's what I live doing all day long. And then in my side hustle, I come to Latin America, and I do coaching and mentoring and talking and speaking. And I'm a big fan of the Whopper. And I was doing the Whopper workshop on performance and reliability in the States for many, many years. And it's great to come down and be with the Whopper teams down here, which is really great. My current employer is FreedomPay. So anything I disclose to you today about FreedomPay is probably something I'm not supposed to be talking about. But that's okay. Then on the side, I actually do a bunch of things under performacology. So you'll see some videos coming there very soon, which would be very nice. So today, I just want to introduce this idea, how we have leveraged at FreedomPay using observability tools and telemetry within the systems we're testing in order to make what we're doing in test automation and quality more robust and more interesting and valuable. So we're going to apply that. Also augmented tests. So if I have a test, anyone familiar with augmented reality? In Espanol, augmented. Yeah. Aumentada. That's nice. Aumentada. So augmented reality. Well, think augmented reality would be in your glasses or something visual. Imagine that in your test. I augment my test, right? So augmented testing. So improving that. And then where might we pull in, at FreedomPay, where do we pull in AI to do things and start passing or failing based on what the AI tells us about these signals? So the testing challenge traditionally for testing financial systems, anyone, hopefully you're in this track, you're working for a bank, payments, basically anything to do with money, taxation, if you're working in a tax office, any type of taxation would be interesting. The biggest challenge for a long time, we just say complexity. And everyone generically says, yes, it's very complex. Anna's job is complex, my job is complex, your job is complex. Everyone has a complex job. The person driving Uber has like 3 or 4 jobs. That's very complex. So it's not really the biggest challenge. Everything's been complex for decades and decades and decades. So then I think to myself, integrations. In the financial systems landscape, it's not like a fresh, happy mobile app or a single website. It's a collection of generations of integrations between banks, between systems, between processors and creditors, and in all of this financial system, the integrations. Well, that's true. My very first system test in a banking was mortgage lending, and working with mortgages, we had 5 or 6 main integrations we had to do from the crediting and the underwriting mortgage piece. So integrations, not really the biggest challenge. But in 2025, my thought is testing blindness. So I'm blind as a tester because of complexity, and our traditional way of testing complexity is just hire Gus. He's really smart. Hire the smartest, most talented. Hire Claudio. Just get smart people, and the smart people will solve the complexity. Well, have fewer integrations? Well, that didn't work out. We have more integrations than we ever had. So making everything more observable is the biggest challenge. If I'm trying to test something, and the traditional black box testing, or I like to call it blind box, right? It's a blind box test. I cannot see into it, where observability helps every tester start doing what we call gray or white box testing, or transparent testing. And so that's, to me, the biggest challenge. If we can see it, if we can touch it, if we can monitor it, measure it, if we can capture it during a test case, then we can overcome these challenges more easily. And also, because we use these wonderful tools, it's all automatable, right? We have an AI to do that. By the way, again, here is the tester struggling to test what they cannot see. It's perfect. Yeah, love it. So I gave birth to this idea of observability-driven testing. If you were working comparing to other TDDs, right? It's a quality practices that leverages telemetry data to specify and evaluate test criteria. So I am specifying the acceptance criteria based on data, attributes, metrics, logs, anything extracted from the gray box, from the observability span log itself. And I'm using that as the evaluation criteria, pass or fail, or a collection of pass and fails. So if you compare it to test-driven development, that test-driven might say, hey, did I write the right code? I wrote my test, the code passes the test, the code is right. But doesn't really tell you much about how it's going to work in the real world. It doesn't tell you much if it's a blind box. You can't, well, I must have written the code right. I can't see the code. I don't know what the code is. Those days are long gone. If you compare it to behavior-driven development, comparatively, it might say, behaviorally, does the system do the right thing? Does it behave in the right way from a test perspective? So I come up with the behaviors. I maybe even write them like business cases. And as long as the business is happy, we pass. Whereas observability testing kind of says, will this whole freaking thing even operate in the real world? And actually, can we see when it doesn't operate is the secondary question. So one, will this thing actually work? Does it show any indication of something that would fail the test, even if the behaviors pass, even if the GUI passes, even if the code is technically correct, it's going to fail in production. So observability-driven testing is just a new way to think of that, of breaking out of the blind box paradigm, if you will. I called it a paradigm. Yeah, that's right. Okay, I invented a paradigm. So gray and white box testing. And again, I really like the space astronaut with the antique sack. If you want any of these pictures, just let me know. They're really awesome. So how do we go about doing this? We pull observability signals into the test. So you could take the frequency or count of a given span, a particular call, an API call. Not the that did it call or didn't it call, the behavior, but how many times did it call? The metric in terms of a count or frequency with a particular attribute. So I'm executing a function inside the app I'm making. I should always see 3 calls in this sequence, and that count should always match. And that would be an observability or an attribute of that trace information. Metrics. So whenever we submit a particular payload, we know it should be within these boundaries. So there's a min and a max or an average in terms, or maybe even exact number. It should be exactly this number of bytes because we're only allowed that size payload. So you could be very specific, but it's normally a performance metric, but you could measure it just for one test. Just, yep, that many bytes went between point A and point B. That looks right. If suddenly the test passes from the GUI or from the system, the API call, but the payload now became huge, you could fail the test based on that metric. But a manual tester might be like, looks fine to me. Woohoo, ship it. Log attributes showing timestamp. So what if you're time stamped? You've got timing issues within the code, and you get something that's stamped. I saw this recently in our code where we did a bunch of work, and then after all the work, there's about 3 seconds, and then start, end. Somebody had tried to code the timestamps in the logging and did all the, well, let's do the logging at the end. Great, even the start message. So that was completely wrong. It would be very misleading, so we failed that. A particular KPI, so let's say there's a metric on a physical metric. It could be a logical metric. Hey, we have to have these many, we can only do n number of calls to the database or the data source. You have the existence of a KPI and the measurement of the value being two separate things. So is it observable? Yes or no, pass or fail. Yes, it has to, this KPI must exist for us to pass the test. The value of the KPI, we might put that in the performance test. Well, when this thing is under load, that KPI has to equal a certain value under load. But the functional test is the KPI itself, the metric, the element, the component has to exist. And then, of course, some sort of metadata state, a crash or an exception. I had customers, testers internally, where the functional team was, every time they ran the test, it went through and made like 200 payments of different, boundary tests and functional tests, the automation, and they're like, are we good to go? They're like, yeah, let's ship the code. And then I opened up our observability tool and I showed them, how many test payments did you run on that case? Well, it's 215. And I'm like, here's the history of exactly 215 execution crashes, actual crash dump files. But again, behaviorally or functionality-wise, yeah, we're good. But if I look at what's happening behind the scenes, not a performance test, functional test, they were not looking at making the, did we crash the executable, a non-functional test criteria. We need to pull that in. So that's one of the ideas. In enhanced acceptance criteria then would include those observability items within your test criteria. Now in financial systems, you would just augment with other attributes. So a particular trace attribute that you would have on a span for something like amounts or line item details. I put these many line item details on a payment purchase and I need to validate individual line items. And sometimes that data is not available unless you do all these payments and then go to the database. And I'll show you our one case where we have that. A metric showing fee calculation. So if you're calculating aggregation fees over time for a given terminal or something like that in the real world, those fee calculations may change. A log attribute that's showing that a certain amount, a particular transaction amount or something is sent back and forth to a system. So you can think about like a refund or credit has to match that particular input. But in the real world, you might be, I'm blind to that. But with observability, you could actually pull these attributes out and compare them as part of your test criteria. So, what good is testing if you can't stop really, really, really crappy code? So a quality gate. If I think of using this observability data, I can now embed that into the gate. If I'm automating against a quality gate to stop something, one, incorporate all of those signals from metrics and logs and insights right into the gate itself. So if these metrics, if that KPI didn't exist or something, you're going to gate the automation release on that. The system telemetry itself is just sort of continuously evaluated at that point. So no matter what, you could have it tied to a specific test case. In some of my teams, I have a set of sort of observability gates that are separate from the functional test results. So together, everything should be green. In another team, they put them right together, and I actually prefer that. From an ownership and management maintenance, it's much easier to put these together as a single test criteria. But you could have error rates, anomalies, different scores, and again, you could have a functional test that passes functionally, yet give evidence within the traces or in the logs that something is unhealthy. So that's a good way to think about it. And yeah, observability-driven gates and augmenting that. So if you transform the gate from that, should I push or not push, deploy or not deploy, you actually have a more meaningful validation of the greater context for the future of that application. Will that application, is it predicted to fail in the future? The main question, I think, is it observable? So one of the things like looking for a KPI, if you are instrumenting your code with OpenTelemetry, and you need to have certain, wherever you see transaction amount, we need to expose that as an attribute. So testers more technically can test, is this observable? Do we have test requirements around, hey, you can't just push blind code into production. Everything needs to be appropriately instrumented. It needs, in financial systems for us, you have to pass compliance. So we review every attribute, obviously for PII and PCI data, card data, but also any financial data or regulated industry like medical records or something. So you're reviewing all of that observability instrumentation. And we have like a 5-step process for doing that, which is pretty cool. The other thing you can do is look at a sort of a percent coverage. We love coverage statistics in testing, right? Code coverage. Well, there's also observability coverage. So what percent of the code is observable and what percent is deemed by any stakeholder? That's kind of blind. That's a gap. We can't quite see into that. Well, can I put some logging around that call just to help, you know, I could have an OpenTelemetry, a trace, spawn a span. Maybe I don't even enrich the span, but at least I have a span that says this is happening, even though it's a blind spot for the whole system. So you could calculate a percentage observability coverage as well as part of your piece, as part of the approach and strategy. The other aspect of this is obviously we'd be remiss if I didn't say, gosh, I've got all this rich data. Not only do I have my test data, that's the configuration. I have the test case movement of data over time. I have the system configuration available to me, even though I never really thought about that in my tests. And now I have all this observability information from when the system is active and being exercised. And there's nothing like machine learning to love data. So if you can feed all of this data, the ultimate goals for you would be to enhance this augmentation of test cases, to actually have AI is really great at looking at patterns in the chaos. So if you can feed it data and train a model, you're now looking at that signal amplifier. So we have a high hit of whenever this function happens, the application crashes. Okay, very simple binary 2 data fields to do that. But imagine looking for patterns as a tester where there's 12, 15 different attributes being pulled into the feature data. Well, you could train a model to go looking for those kinds of anomalies. Anomaly detection is not just for production. You can start doing that within your test cases. In a way, you can do it more reliably because the test cases are they're not very diverse from a chaos perspective. It's kind of very clean. We know exactly what the input data is. The only thing that's changing is the code base or configuration for that test. So there's all kinds of ways that you can leverage this observability data in a test context and not just use AI for doing, you know, obviously we can make test case discoveries. Where would I find tests? Are there good any anti-patterns to be found within the chaos? You can look for early warning systems of anticipated failure. So you're looking for that count or frequency of a given call, and suddenly on Thursday, on the 3rd week of the sprint, there's 40 of them. There used to be 2. Okay, it passes the test, but if you push that to production, somebody's going to be like, whoa, 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 you're doing like 20 times more work. What is going on here? And the database team is like, yeah, exactly. But I really like the predictive quality piece because if you get into more continuous testing, more repeated testing on a very common basis, you've got a trend of data that you can run regression against. So whether it's a zero score or a Holtz-Winters or any of the algorithms you could pull conveniently from your observability tool, you can use some of those predictive forecasting. So each time you run your regression test, you can start looking at the predicted values, your predicted test case failure, your predicted change for production, etc., could make it easier to extrapolate what's going to happen in the real world. Leveraging predictive quality, if it's a good enough confidence in the model, you can start failing a test based on the prediction. So the actual test is green. Your prediction is red, is failing. So you could actually start gating on predicted future values. Hey, this looks like it's green, but there's these other indications within the model that show maybe this isn't stable enough for production. Maybe our data sizes moving back and forth was unexpected. I don't know why I'm moving that much data. It works, yeah. It's secure, yeah. Perf team wasn't quite looking at the network adapter between those servers, and I've doubled my payload size. And did we estimate for that? That kind of stuff. So think about prediction, the actual result of a predictive algorithm being used for that. So here's a case study for our business case. One of the things we love to do is moving to real-time settlements. If you've ever run on the payment space, you're waiting until the end of the night. They run a big batch. Sometimes it's really noisy. It's usually a really, really expensive process. If you have a merchant that's doing a couple $100,000 from a single terminal in a given day, you could have a $5 million batch settlement that fails, and they're not going to get paid. Settlement just pays the IOUs back to the merchants. So we like giving merchants the ability to get paid immediately. Customer charges, we get notified, we get paid immediately. Obviously, we can, settle in a more hourly or a more real-time basis. So that's the goal, right? Now, our current test approach was very old school, right? Run a bunch of transactions, they go into the system of record, wherever that is. Then we run the batch job to calculate all that kind of stuff in the batches. At the very end, we just check the database. So while this thing is running, nobody's looking inside the blind spot of the batch processing itself. The developers know what they wrote. Do they log stuff? Well, that's on a system over there of the thing at the time and the SQL agent. You can't really, oh, wait a minute, you're testing X, Y, and Z. You don't have access to that system. All of the old school challenges of just, I need to see inside this batch job. So with observability, we can enhance this. So as you run the transaction, we're now logging out the attributes about each one of the transactions so we can compare an expected result to what that should be at a more granular level in real time. We do some dynamic adaptive routing. So even though we want to make sure it's like, well, you're getting this fee structure and you're getting this settlement for that fee structure, but the test actually dynamically routes to different processors on the back end. Very interesting. So we can check span attributes for the dollar fields, the amounts, and we can also look at where that transaction was by the engine, where it was routed in the smart routing. So we can do all these calculations on the fly. We can look for the metric count of DB calls to be greater than 1 on that settlement per record. The transactions are closed immediately within the test itself. So as the test is running, maybe that batch job in testing takes 45 minutes. Well, if I'm starting to have a repeated bug failure, I see it on the first transaction. I don't have to waste 45 minutes of my test life, then run a test to check the database. And if I do that, I'm leaving myself open for false negatives because there could be something wrong in the transactional processing, but the last step does some calculation. There's a bug hiding in there. So if I have a value on the fly within each calculated record, I can actually see that as part of the test case processing and flag them as failures, even though the very end state, well, you pass, it's green, all the records are there and it's good, you're good. Like, let's say you have 4 steps, and the first 3 steps are actually calculating it wrong. But the 4th step comes in, woohoo, makes it right. We've masked the 3 incorrect steps. Well, what if somebody changes that 4th step, and suddenly it's got a bug? It's no longer healing or covering up the mistake. Oh, no. Suddenly you've got this bug, a vulnerability sitting there waiting to be exposed. So we can do more real-time analysis with that. So that's kind of the shift that we're seeing, is getting our test teams to think about more granular, immediate test case pass and fail while it's running. Just a little example of an observability tool that has a trace over on the left side. On the right, these are all the different attributes we're talking about. Here's a list of those attributes. You can put them in span attributes in OpenTelemetry. Different tools have different approaches for the instrumentation, but you're exposing elements in there. It's maybe a little bit hard to see, but there's like the processor ID, the attribute, the client IP. You could get the functional, the transaction amount, all those different pieces that are in there, right? So I'm exposing that from the code in real time. There's also the logging. So I'm pulling my traces with the trace attributes with the logs all together. And this is one test run. So I can see for that piece, and then, oh, isn't that nice? Thanks, you're throwing exceptions behind the scenes. And now, granted, maybe we're making lots of money every day, but I don't like exceptions. Exceptions take up resources, they chew CPU. They should be exceptional, like never happen. So again, testers are now able to see code health at the code path level. I think the main thing for us is the lessons learned are to just get started. I started with one team that was doing this for e-commerce, and my second one now is this batch, real-time batch settlement. So start small and start picking a few key attributes. It's, hey, could we see whether it's going to pass, or pull an attribute and put it into the test case criteria for pass-fail. Break out of that blind box, the black box testing. It makes testers even more technical. We're deeper in the code. When you're having a conversation with your developer, you know method names, class names. You're living within the code with them if you've never done that before. So your engineering exposure becomes much higher, and you can collaborate at that level much better. I had a lot of work to do with DevOps and SRE, the code pipelines themselves, plus readiness to production to correlate some of the KPIs from production. We pulled them all the way forward into QA so we could start validating those. So make buddies, make friends with your DevOps and SRE teams. And then, of course, I think generally it's always good with governance to say, is this something we would ever be audited on? So if they're like, oh yeah, we have to go run this weird report once a year for compliance, and they were like, can you expose that in real time in production, but can we also drive it all the way in front, put it right in front of the tester's face? It's like, yep, that's a compliance criteria that we didn't really call out. They just, oh yeah, there's a field. Nobody thought, wow, wait a minute, that's an auditor and somebody suing us in a lawsuit, or there's risk associated with that attribute. Let's make sure that we test for that exactly, which is really, really good. And that's my brief tour of observability-driven testing. But I want to give you some questions to take home with you, and things. If you want to take a screenshot of that, just take a picture of it. How would you augment a given test case that your teams are working on? How would you bring, what kind of observability signal would you bring into your tests? How would that change the meaning of your tests as well? So the meaning of a test result changed. So not only is this functionally failing, when we start putting security in there, okay, now I'm thinking, put on my security hat, I may be failing from a security perspective. While I put on my operations hat, I might be failing from, oh, wait a minute, we have these other metrics that are wrong. We're abusing the database. We have try-catch exception issues, right? Another thing to ask, how observable is the pipeline itself? So can I look at how often I'm testing those coverage statistics? How observable is the test harness and the regression tests? Which ones pass, which one fail? So am I using observability metrics or information about my actual testing pipeline in and of itself? Fantastic. My DevOps guys are like, we just push the button. And I'm like, well, what do you mean push the button? Well, they check in, and then the thing, and then the manual. I'm like, first of all, why are you doing that manually? Second of all, like, what could we just have the observability tool govern those metrics for us? And lastly, do you trust your test results? I had teams that were given a total thumbs up to a test, what I would call a false negative, and when we started pulling away and turning on the X-ray goggles of observability, they were like, oh, yeah, that's not passing. I'm like, yeah, so maybe we should like make that trace part of your test case, pass fail. Oh yeah, great idea. I sort of gave birth to that from a financial perspective. And that's all I have. I think I got through. I kind of shortened it just because we came back from pizza.
Yeah, thank you, Mark.
I also want to leave some Q&A open.
We have now a few minutes for some questions, if someone have. Tenemos ahora unos minutos para unas preguntas. Si alguien las quiere hacer en español, también lo podemos traducir ahí.
Did it work?
Yeah.
Okay. Questions? Gus.
Para que te acerco el micrófono.
For the live streaming people.
Okay. Prefiero hacerlo en español, si no es
Try
molestia.
it.
Sí. Un aspecto clave en lo que comentaste fue, es observable nuestro código, y quería que me contaras cómo es la experiencia en tu organización respecto a justamente implementar esa observabilidad en el código. ¿Qué tan fácil o qué tan difícil es lograr que se instrumente tu código para que los testers se puedan beneficiar, pero me imagino que también otras partes de la organización también se benefician de esa instrumentación y ese aumento de la observabilidad?
Yeah. Okay. So, getting it into the automation framework itself was because almost all of the observability tools have an API that you can integrate, you can pull data from them. Some of them even have components custom built for, say, Postman scripts or custom scripting. So we just started using the REST APIs from the observability tool to pull that in. In some cases, the teams had a custom test tool that we augmented their test traffic, let's say in an HTTP header or a TCP header, where we enriched the same way the observability tool does the tracing or an X-trace header of some kind, telemetry header. We put our own custom expected result in the header. So when we sent the traffic on, the observability tool says, aha, you're for the application, you're going to, oh, thank you for this header. Now my observability tool knows what the expected result is. So it knows what the actual response. So now my observability tool can compare what's expected to the actual, I have a test case condition. And then I got into adding multiple expected results. So check these 5 fields, and check these 2 metrics. And I could actually run all of that inside the observability tool with its own queries, with its own piece. So I would pass in something like the date and time and a unique ID for that test run. So this is the 3 p.m. test run of the credit card processing job. And it has a test run ID 1234. So I can go into my telemetry tool, for us it's Dynatrace. I go into Dynatrace, I could look for, show me all the traffic for test run 1234. So one thing is using a way to enrich your test traffic with expected results per test case, with unique ID for the test run, date and time, type of test, the name of the test. Anything that you would like to come out of Grafana or out of your tool to say, hey, I can see my test results. The alternative for this team was to not do that, live in their custom test tool, do all sorts of logging, pull all the data out, put it into SQL Server, build a Power BI reporting engine on top of SQL Server, and then produce a bunch of reports that had 0 information from the observability tool. It was old school, just my test tool says it passed. So I'm like, that's no different than the blind box. Like, oh, my test tool said it passed. Did you look at the logs? Nope. Did you look in the database? Well, we have a database checkpoint. Well, when did you check the database? At the end of the test, not during the test. So that's kind of how I was like, well, what if we could annotate or enrich the test traffic itself? Now I can see every step associated with that test case in that tool. That's kind of the technical approach for doing it. Now, I had to work with development, architecture, make sure that the headers, especially in TCP binary, the TCP headers, that's very sensitive. So we did appending, not prepending. So usually the offsets in binary, if you added stuff at the end, it would just ignore it, which was fine. So the application would not change, but we could pull that data out from a binary perspective. That was fun. You get a blob, and then it's like base 64 decode. You got it was fun. We didn't have to do much of that. So does that help? Yes. Kind of that's how you would get the automation to start listening as well as talking to the observability tool. They become one. Yeah, great question. Does anyone a follow on to that? Or we have 3 minutes.
No, we are on time now.
We're done now?
Yes.
We're done
But
now.
maybe out, they can ask you.
I'm here, yeah. Catch me outside. That'd be fun.
Okay.
Thank you guys very much. Muchas gracias. Buen días.